Greetings YouTube, Beautiful Mind here, and we're going to continue this is going to serve as the last section. Oh, wait a minute. Let me do this real quick. All right, let's try this again. So, for some reason I have to reboot it. Sometimes it gets real laggy, so I was like, I had to reboot it. Okay. So, this is going to serve as the last section for chapter 2. We're going to be looking at exponential and log functions. Maybe if I go like this, maybe that's why it's so laggy. Yeah, I'm gonna just kind of trust it. Okay, so this is the last section for chapter 2, the derivatives of exponential functions base A and log functions base A. So we want to differentiate functions involving a to the power of x and differentiate functions involving log base A of x. Right? So the derivative of exponential function base A is going to be the natural log of A times A. Remember in the last one, when we did the derivative of the exponential, it was d by dx of e to the x, right? And it was just itself. This part was actually there, but natural log of e is 1, right? So we weren't aware of it because the natural log of e is 1. Can I just hide this? How do I hide this thing? Can't get it off the screen. Okay. There it is. Okay. Let's see. Right? So the derivative of exponential function base A is the natural log of A times itself. So we're asked to differentiate here. So for part A, dy by dx should be the natural log of 2 times, let's write it like natural log of 2 times 2 to the power of x, right? For B, dy by dx, so it should be the natural log of 1.4 times 1.4 to the power of x, okay? And then C, all right, f prime should be the natural log of 3 times this thing, 3 to the power of 2x plus 1 times 2, because we got to say times the derivative of the exponent. Okay. So the first one, natural log of 2 times 2 to the power of x, the natural log of 1.4 times 1.4 to the power of x, 2 times the natural log of 3 times 3 to the power of 2x plus 1, right? I think we got all of that. Okay, that was fun. Quick check. I meant to leave this as an exercise. See, in this form, I can't see my time. I'm going to have to hop back over. Okay. I think for the sake of time, I don't think we have that much. I'm going to go ahead and do these. Differentiate. So then our dy by dx is going to be the natural log of 5 times 5 to the power of x. Dy by dx, nope. F prime, natural log of 4 times 4 to the power of x. Dy by dx, natural log of 7 times 7 to the power of x squared times the derivative of x squared is 2x. Okay? Natural log of 5 times that, natural log of 4 times that, Let's see. Okay, so the 2 can go to the exponent and it becomes 7 squared, which gives us 49, right? So we could take it a little further. I did stop a little early. Okay. So then I think last time when we did the derivative of log of the natural log function, that was just 1 over x, right? But remember, that was when we had base e. So this guy was just 1, so we weren't aware of it. Now if the base is a, something other than e, then it's going to be 1 over the natural log of a. Basically, 1 over x natural log of a. Okay, for the derivative of the log function base a. All right. So given these, we're actually differentiate. So if we look at part A, so our dy by dx, 1 over x natural log of a. So it should be 1 over x times the natural log of 8. See b, dy by dx. So that's base 10, right? Let's see. It should be 1 over x times the natural log of 10. Let me make sure I'm doing this right. Let's keep going. C, so f prime, so 1 over, you still have this x squared plus 1 times the natural log of 3, du over u. So then on top, we're going to have the derivative of the inside part, so the 2x. Right? Can I paste? Is that still? No? Okay. I'm just boxing my final answers. Ugh. Okay. Let's just do it like this. I'm boxing my final answers to make them kind of jump off the screen. Copy. Copy. Nope. Undo. Paste. And I know we have one more. We're about to do it. Okay. Let's see. D. That's not a D. F prime. So product rule, right? First times the derivative of the second. So that's going to be 1 over x natural log of 5. The first times the derivative of the second plus the second times the derivative of the first, which is 3x squared. Ran out of space. I can't leave that like that. I'm going to rearrange a lot of this stuff. First times the derivative of the second plus the second times the derivative of the first. I think that's about the best we can do. Okay, I'm going to shrink. First, I want to rearrange this stuff. I'm trying to get it on one line. Let me go ahead and do this. Shrink all of this down. Put this like here. Let me copy and paste. So I'm trying to keep them uniform. I didn't want to draw a box. I wanted them to be uniform. Okay, that was the main thing. And then you know what? I'm gonna do this. Move this one down, and I want to move this one like here. Okay, then I'll expand it back. And we're ready to rock and roll. Okay. All right, let's go with this and see how do we do. My mic might be a little bit high. Okay. We got 1 over x natural log of 8. That's fine. 1 over x natural log of 10. 2x 2x natural log of 3x plus x squared plus 1. Okay. We got this long thing here. Oh, we divided by, I totally did not even try to simplify. Because like right here, let me at least mark it. This x can turn this into a 2. We could factor out an x squared from both terms. Let's see how they want the final thing. So they left them separated. But I think we got it. We got everything else. Okay. That was a fun one. Oh, that was too short. That's a quick check. I usually leave quick checks for you guys. I think you can handle it. Okay. I'm going to leave that for you. All right. So that one wasn't too terribly bad. It was just an introduction to taking the derivative of exponential functions base A and log functions base A. All right. And how do we differentiate? Okay. So on that note, we're going to end this session here. And from one beautiful mind to another, enjoy the rest of your day. Peace.